Okay, so summarize of what I didn't record is email me if you need help with linear algebra. I would have needed help. Today, choose 2 of the 4 problems on the quiz I'm going to hand you. On the quiz. Future. What is in the future? Okay. So for that, we will zoom out. The updated problem list. Of course, it has your familiar 1 through 13. But now, what is problem 14? So I'm going to talk about this before we take the... After I talk about this, we're going to take the quiz. So this is your assignment. It's graded, but it's not graded on whether you've completely solved this problem. It's graded rather on your ability to clearly and coherently explain the many investigations you undertook this week. So this is going to be a fun week, because I gave you a hard problem. And it's pretty awesome because you're going to have to visualize something that lives in 4 dimensions, which I find really fun. I hope you find that fun. It's also very useful, because almost every real-world problem lives in a higher dimensional space. Even if it doesn't seem like it, it does. So, what is the problem? You're going to choose one of these 2 varieties. This one is a torus. However, it's not the torus that you know and you eat with coffee. Okay? It's a different torus. It's the more natural torus, actually. Maybe you could call it a Clifford torus. Clifford torus, this comes up in physics. Anyway, it's a torus and it lives in 4-dimensional space. The other one you could choose, if you prefer, is the statistical independence model on 2 binary random variables. Okay, so this comes up in statistics. Alternatively, it is the Segre variety, if you like algebraic geometry more than statistics. But they are the same. And, well, it's a slice of the Segre variety. But either way, it is a set of 2x2 matrices of rank less than or equal to 1, and whose entries sum to 1. So those are your 2 choices. When you pick one, first you're going to give implicit equations defining it. Then you're going to give a parameterization by rational functions. Then you're going to generate a text file with 1,000 points on it. This means you're going to generate a text file that has 4,000 real numbers, ordered in groups of 4. Then you're going to use a computer to visualize it. There's several ways I could think of to do this, but you'll have to think of one. Then you're going to compute a basis for the tangent and normal spaces at arbitrary points, so at any point. Then you're going to write down an integral that computes the 2-dimensional volume. These are both 2-dimensional varieties living inside a 4-dimensional space. You're going to write down an integral that says its volume, at least on some subset of it. And don't choose a 0-dimensional subset and say it has volume 0. Choose a 2-dimensional subset, okay? It'll have non-zero volume. You don't have to actually compute that integral. You could numerically compute it, probably. Then lastly, find a point that is closest to this point. So this point, I guarantee, is not on the variety. It's somewhere else in 4-dimensional space. Your variety is over here in 4-dimensional space. This point is right there. Find the closest point on the variety to this point. Okay? That's the last part. So if you're like me, you'd be looking at this and say, I have no idea how to do any of this. Okay? That's why this week's going to be fun. You're supposed to research, right? This means go to the internet. Search anything you can. Find whatever you can. Read Wikipedia articles. Also, email me. Of course, I'm not just going to give you the answer, but I'll give you hints and I'll help you. Probably what I'll do is you'll email me about some problem you can't solve, and I'll email you a simpler problem to try to solve. And if you can't solve that one, I'll email you a simpler problem, and this is how it'll go. But either way, you will definitely learn by emailing me. And perhaps we'll also reveal parts of linear algebra that I could help you with. So this is going to be sort of a very different week. What I expect is that 2 hours a day this week you're working on this. It's going to take a lot of effort because this is a hard problem. However, it is absolutely algebraic geometry. These are algebraic varieties, and this is questions about their geometry. So, yeah, I think this should be pretty fun. If you like, you can use Overleaf. That's what I recommend. But if you've never learned LaTeX before, or never used it before, maybe you're not going to enjoy that so much. So you can also write it up by hand, provided it's very neat. That'll also take you longer. It's faster to type mathematical symbols sometimes and edit them. You could, if you're going to use a computer, so if you like Jupyter notebooks, you could do this whole thing in a Jupyter notebook and turn in the Jupyter notebook. That's an option. You could turn in a Sage worksheet. So if you're going to use CoCalc, which is on our Canvas homepage, all the links you need are there. And yeah, as always, email me questions. This is sort of a research project for you. I don't think you're going to be able to find the answer on the internet, like verbatim. I don't think you'll be able to find it. But if you can, that's great. You solved the problem, right? If you're a research mathematician, part of that is figuring out if somebody else has solved this before. Okay. Google's not good enough, I don't think, to find this for you. But maybe it is.
What does the product of the one spheres mean?
Great question. So Cartesian product. So first of all, what's S1 as a set? Does anyone know what S1 is as a set? The way I write down as a set is I write something like this. And then I write what?
Set of
Is it
points
the set of-
x, y,
Yeah.
x and y and r, such that x squared plus y squared equals 1.
That works. And then you have to do something like that.
So it's a sphere in one dimension, which is to say. a
This is
circle.
S1, yeah. So now what's S1 cross S1? The Cartesian product will always just be, well, x, y, not done, AB. X, y, AB, and then you make AB satisfy the same thing. So let me write it down. I actually prefer, because then you get so many symbols so quickly. I actually like to write x1, x2, x3, x4, such that the x1, x2 sum of squares is equal to 1. The x3, x4 sum of squares is equal to 1. Okay. But if you forget this, email me. All right, so any of these kind of questions, I can help you get started. You can also search the internet for figure out what these things are. Okay, so this will, when you leave today, you should start working on this because it's going to take some time. And when does this due? Well, in Canvas, I will open up an assignment where you can upload this. So you upload a PDF. If you choose to handwrite it, which I think will take longer, you'll then have to take pictures and upload it to Canvas. Yes?
Do you want us to write it up kind of like our homework journal with like what time we work on everything?
Excellent question. Actually, no. So this one, I want it to be more like a finished product. Your homework journal is just like this mess of, well, it should be a mess of you just trying things over and over again. But this one should like read. I should be able to just read it and really, a big part of this is you explaining in words and formulas your thought. You know, essentially, why are you correct when you solve this? Me?
So do you expect it to be like a formal proof or something like that?
To be what?
A formal proof.
A formal group?
Formal proof.
Oh, I see. No, not a formal proof, no. Because parts of it may be a formal proof, but you don't have to get that formal with it. This is more I don't know, like an investigation. It should be, when I read this, I should be able to construct a formal proof if I like, because you've got all the information there. Yeah, that's if you've solved it. Otherwise, if you're just exploring and you don't solve it, that's certainly not a formal proof, but it can still be good. It can still be an excellent assignment if you explain your investigations and your conclusions based on the experiments you made. Yeah. Okay, questions? Alex and then Kimmy.
So why does the term 3-sphere or S3 refer to a sphere in R4 instead of a sphere in R3? Like, why is that?
Well, yeah, it's just a choice of notation. I think the 3, or like S1 refers to the fact that this is a one-dimensional object.
Ah,
So S3 should be a 3-dimensional object. In order for that to be true, it has to be the one that's in R4. And in fact, this one, I believe, lives inside of S3. So this little torus is a 2-dimensional subset of the 3 sphere that lives in R4.
huh. Okay.
It's probably the 3 sphere of radius root 2. Because if we sum all the squares, we don't get 1 anymore, we get 2. Okay, it lives in the sphere of radius root 2, but it's still a 2-dimensional subset of a sphere. Kind of interesting. Oh yeah, Kinry, question, sorry.
Are we allowed to talk to each other?
Yes, you are. Yeah. One of the best ways to do math is collaboration. So the internet is a resource. Your next door neighbor is a resource. The people you meet on the street are resources. Professors Rana and Sattler and Corey are resources, if you can get them to tell you things. Yeah. At the end of the day, though, you need to explain whatever you found on the internet or in somebody else's office, or from me, you need to explain it in this written document. So, to solve this, I picked this one, and I solved it in about an hour. But that's because I've already worked with these a lot, so I knew them. I think it's going to take you much longer than an hour, okay? Yeah, some of these are like... Okay, so what should be clear is we're not moving on to section 4 yet. We're going to slow down and take some time to really... This will force you to remember some of your linear algebra and calculus, which is absolutely crucial before we move on to the abstract varieties defined by their ideals, which is section 4. Okay, so this piece of paper may be enough, the front and back, but you might need another piece of paper, so but for now, just start on this. And you can take out some scratch paper, for example. But either way, just put all your stuff away and like the IH. I actually need how is IH?
IHRTLUHC.
I
Oh, yes. Okay.